Hello everyone, and today we are going to solve two questions from paper 1. First question is from paper 1, question number 5E. Okay, 2021 Civil Service Mains paper, paper number 1. So what the question is, a mechanic needs a gauge for checking the diameter of holes to be machined to a diameter of 30 plus 0.06 mm. So diameter of the hole is 30 plus 0.06 mm. Now, what should be the dimension of the gauge if unilateral system of tolerance are incorporated? Okay, assume the gauge tolerance and wear allowances. Gauge tolerance and wear allowances each as a 10% of the work tolerance. So first of all, let me let me show you about how this gauge is looks like. So this is the gauge for checking the holes, and this side, these two sides, this is the go side and this is no go side. Okay, so this go side is going in the hole to check the whether the size is correct or not. So due to continuous operation and frequent operations, uh, continuous sliding between the two surfaces of hole and the gauge, so there will be, obviously there will be wear. Okay, so we have to give the additional allowances, and some tolerance is also there because in no part is exactly accurately manufactured. Okay, so there will be some tolerance we have to give in the hole as well as on the gauge. Okay, so what is this work gauge tolerance and wear allowance both has a 10% of the work tolerance. So what is the work tolerance? So this 0.06 mm is a work tolerance. So let me write here, work tolerance is 0.06 mm. Now what is the gauge tolerance? Gauge tolerance, that is 10% of the work tolerance, that means 0.006 mm. And what is the wear allowance? And wear allowance is also 10% of the work tolerance, that is 0.006 mm. So what we have to do is we have to do the summation of all three. So you will get 0.072 mm, and the basic size is 30 mm. So what will be the dimension of the gauge if unilateral tolerance? Here we have incorporated unilateral tolerance system. So size of the gauge will be 30 plus 0.072 mm. So this will be the size of the gauge. So this is the answer, and this is a very easy question of 10 marks. You can easily score this. Next, we will going to solve question number 4B of paper number 1. This is very interesting. Yeah, it's easy, but it's a quite small calculations are there. If you do the mistake, then your answer will be wrong. So question number 4B from paper number 1. An inscribed circular hole is made in a triangular lamina with each side of A. Find the area moment of inertia of this lamina about one of the sides. So this is the figure looks like. Here I have assumed the triangle ABC and the circle inscribed in whose radius is R, and we have to find the moment of inertia about one of the lamina, one of the sides. So we will consider the moment of inertia about this base line, this base BC line, and this is the circular hole that has been cut out. Okay, so what to do is we have to write first. I'm writing the moment of inertia I is equal to I1 minus I2. I1 is what? I1 is for triangle and I2 is for circle. So first of all we will find I1 for the triangle. So I1, the area moment of inertia for triangle about its base is 1 by 2 base into altitude cube, 1 by 12, 1 by 12 into BH cube. So what is the base? Base is the A, but what is the height? This height H. So we have to use Pythagoras theorem. So when you use this Pythagoras theorem, A square, here when you bisect this triangle from a vertical line and make a point over here D. So A square is equal to this, uh, A square is equal to AD square plus BD square. Okay, A square. What is AD square? That is we have to find our H. that is h square plus bd square, that means a by 2 whole square. So h will be root 3 by 2a. When you solve this, you will get root 3 by 2a. Now put this root h value over here, so you will get I1 value as a end side equation number 1, and I1 is 1 by 12, b is a, h is what, root 3 by 2a whole to the power cube. So when you simplify this, you will get as a root 3 a to the power 4 divided by 32 I1. Say it as a equation number 2. Now what is the I2? I2 is the area moment of inertia of the circle about which axis? This BC. But we know the formula for the area moment of inertia of the center. Suppose this is XX. So we have to use the parallel axis theorem. So I2 will be IXX plus AH square. H is the perpendicular distance. So perpendicular distance is R. So plus AR square. So what is the IXX? We know pi R to the power 4 by 4, or in terms of diameter pi by 64 d to the power 4, plus area. Area is pi R square into R square, that means R to the power 4. But we don't know the R. The main thing is find out the R. So one thing that you have to remember is what is the area of this equilateral triangle. This area of this triangle is root 3 by 4 a square. And what is the semi perimeter? Semi perimeter, that will be 3a by 2. The perimeter is a plus a plus a, that is 3a, and half 3a by 2. So radius of the circle is given by area upon semi perimeter of the triangle, not the circle but for triangle. So root 3 by 4 a square into 3a by 2. This one a will be get cancelled, this 2 will be get cancelled. So you will get as a radius. Radius is a by 2 root 3. So radius of this circle is a by 2 root 3. So put over here pi by 4 into a by 2 root 3 to the power 4 plus pi into a upon 2 root 3 to the power 4. Okay, so when you solve this, you will get as a answer of I2. I2 will be 5 by 576 into pi a to the power 4 I2. We have third value, we have third equation. Now what to do? Use 1, 2 and 3 in equation number 1. So you will get I, the required moment of inertia about the base is root 3 by 32 a to the power 4 minus 5 pi by 5 pi by 576 into a to the power 4. So take a to the power 4 common and solve the remaining term. So you will get as a 0 0.0268. So the required moment of inertia is 0.0268 into the a power 4. So this is the final answer, and the unit is power 4. So this is the end of the today's question solution. I hope you enjoyed this, and if you have still any doubt at any point in the video, you can ask in the comment section, and we will meet in the next video with some new questions. So subscribe this channel, like this video, and share with your friends also, and thank you for watching.